The Robot Rogue, and we would like to explain how we went about designing our robot and game strategy this year.
First, we had to design a base robot. We brainstormed many ideas of what we wanted to include on our robot. As a team, we decided on having a square-shaped robot with 2 color sensors, a gyro sensor, 2 motors for attachments, and used the blue cross pins to create quick changing attachments.
The next thing we did was decide what missions to do. Each team member ranked each mission on fun and difficulty. We entered these results into a spreadsheet so that we could view this data in different ways. For example, we took the average and looked for the missions with a high fun rating and a low difficulty rating.
Ranking is not the only idea we used to develop our mission strategy. We also looked at the placements of the missions on the map, type of attachment, and how many points it's worth. Combined, we created our mission strategy.
Because of the fact that Laura and Lydia spent time on how the missions could be done, we started to see how we could combine the attachment types into different launches.
Our first launch is the most ambitious because we attempt to complete 6 missions and the robot fully navigates the table. Half of the missions on this launch use the same lift, up, or down attachment, which makes for an efficient use of our attachment.
We all learned some building and programming techniques this year. For example, I showed the new team members how we can use blue cross pins to make the attachments easier to put on and take off.
We also learned a different way to set up our gear so that they would mesh better.
I also took the time to teach me programming. I helped program the line following program.
While programming the line follower, we learned a more effective way to follow a line. We did this through the use of a correction factor of 0.7.
How the program works is that I take the color sensor reading and subtract it from 50. 50 represents the color sensor value that is half white and half black. By subtracting the color sensor value from 50, we get a new proportional steering value. We then multiply this value by 0.7 to smooth out the churning. We arrived at a 0.7 value through experimenting. We all worked on the robot to various degrees, and we all learned more about the robot building and programming.
We went through the design process multiple times. For example, the treadmill was a very difficult mission for our robot to complete. First, we tried having a gear train spin a wheel to spin the treadmill.
But the wheel was too high, so we moved it down. Then it was too low, so we moved it up a little. But then the wheel wouldn't grip to the treadmill, so we tried another type of wheel. We also were having problems with the gear train having too much friction, so we switched it to using Lego chain.
After many trials and prototypes, we still couldn't get it to work reliably. We then came up with the idea of using the driving wheels of the robot to complete the mission, which worked the best.
We also tried to take advantage of the table whenever we could. For example, we used the walls by backing up into them to make sure the robot was straight.
We also used the lines on the table to help the robot see where it was on the table. We aligned to them, we followed them to navigate longer distances, and also counted the number of lines so we could exit out of the line following loop.
To make programming more efficient, we use MyBlocks. We also have a master program where all the launches are readily available. In our master program, we have a switch block that, depending on which button is pressed, we can go back a launch, forward a launch, or run the current launch.
Troubleshooting the launch programs was something we had to do a lot. To make this easier, we would put a wait block into program that would make the robot pause until we hit the center button. This way, we could see where the robot is on the table before continuing with the rest of the program.
Another troubleshooting method we used was using sound blocks. For example, when we were counting the lines, we would have it say stop when it was to exit the line following the loop.
Using this method, we were able to figure out an issue where the robot would run a launch just as fine as an individual program, but it would fail when using it inside of a master program. It was determined that the problem was related to the way the various loops were named.
We also added in comments so that we could read the program easier, ensuring we changed the right part of the program.
For us to consider a launch finished, it had to work at least 3 times in a row. If the launch we were working on kept failing, we would try to come up with an innovative solution and go through the design process again.
In summary, our mission strategy has 4 launches with 4 quick change attachments. We timed our launches so we would know how long each one takes.
We use MyBlocks to simplify programming, a square design of a robot with easy on and off attachments, 2 color sensors to align to the lines, and we all contributed something to designing the robot and game strategy.